How many boys are absent? 3 are absent today. Fine, boys. I'll go for the first one. Have you taken this? Boys, if you haven't done, then I'll go for. I'll put this in the. You can check the. I've put the slide in your chat box, so we'll go for the. This is a textbook numerical voice. The first one, a string of length, of mass 2.5 kilogram is under a tension of 200 Newton. The length of the wire is 20. It's all mere substitution. 20 centimeter, 20 into 10 to the power of minus 2 meter. If a transverse wave is struck at one of the string, how long does the disturbance take the other end to reach? Right. So now we have to go for what is the velocity of transverse wave. So this velocity v is equal to root of t upon m. Now what is m? M is mass per. This is mass per. Let there be a distinction between this. Just take this as mass. So what is m? M is equal to mass by length. Mass upon length. So the mass is 2.5. Length is 20 into 10 to the power of minus 2. So V becomes equal to root of 200 divided by 2.5 divided by 20 into 10 to the power of minus 2. So that becomes 200 into 10 to the power of plus 2 divided by 2.5. What's the value, boys? So I can write this as 2 into 10 to the power of 4 divided by square root 2.5. So I can make this as
Ma'am, and the numerator 20 is also there, right?
Yeah. Oh, sorry, 20 is also there. Correct, was 20. So 20 means it becomes 4. Then what is the value over here? I can make this as 1, 2, 4, 5. So I'll make this as 40 itself, correct?
Yes, ma'am.
So 10 to the power of 2 goes outside, then it becomes 400 by 25. Is that correct what I'm doing?
Yes, ma'am.
So that will be 8 by 5. Just check, boss. It is 22.5. So I have taken, no, 400, correct. So 80 by 5. 80 by 5 is?
16.
Yeah. What is the value, boss? What is V? Just check.
Is it 4, ma'am? Yes, 4.
4 or 40? Just check. Is it 4 or 40?
I think it's 4.
4.
It's 4, ma'am.
No, just see the calculation what I'm doing. Tension is, sorry, tension I've written 200, right? Sorry, boss. Okay, I think so, correct, boss. Tension is, length is 2.5 by 20, correct. So it comes to be 40. Just check whether it's correct or not. Is it 40?
I'm getting 4.
Fourth. Okay, is that any? See, 200 tension divided by mass per unit length is which period was? Which period? No, I have to be with you, otherwise they will not have. Sir is there, no? Johnson? No, laboratory, physics laboratory, which teacher will be there? No problem, we can do, but teachers should be there. Boss. Some teachers should be there. Just check the permission from supervisor. Because the laboratory lady will allow, the problem is she will ask for teachers to check. So, some teachers that get their permission, physics teacher. Is it 4 only?
No, ma'am, it's 40. You're right.
Now next one. Fine, boys. The next one is, what is the other part of the question?
Ma'am, can you show the previous question? Ma'am, over here, like 20 into 10 raised to minus 2, right? When it goes to the numerator, why it changes to
Wait.
10?
That's the problem, boys. That's the problem. So denominator will be numerator only. Sorry, minus 2 only. That's that became a problem. So then you will have this will be 40. There is nothing like this. Correct? See, denominator goes to the numerator. So 10 to the power of minus 2. So 200, 2 and 2 will get cancelled. So you'll have 40 by 2.5. What is 40 by 2? 400 by 25. So 400 by, so that is
That is 16.
16. Then it will be 4.
16
Fine.
is 4.
Yeah, 4 only. Fine. I think so. The book is showing an error over here. Almost everyone are getting, there is an error in the. What is the time taken? How will you find the time taken? How
Ma'am,
will you find?
velocity equals to length by
Yeah.
time.
So time taken will be equal to velocity by distance by speed. What is the distance traveled? The wave will travel through the length of the wire. Was it 20 centimeter or meter? It was 20, right, boys? What is the speed? Twenty centimeter means what? Length is given as, one second, boys. I have to go for length is given in centimeter. Yeah. Yes, boys. Then in that case, just 5 into 10 to the power minus 2 seconds. Only is that I have to check whether the length is given in centimeter or meters. Let me check this because it's the mistake over there. You check whether the length is in meter also. But this is the way you have to calculate.
Ma'am, in the textbook it's given as meters, but over here it's given as centimeters.
That's okay. That's the problem. Okay. So if it is meter, you can directly use. If it is centimeter, you have to convert it to meters. Since I've taken it as centimeter, you take it as centimeter and then convert it to meters. I'll make this. Shall we go for the next one, boys? Textbook numerical.
Ma'am, so this question we can keep it as centimeters, right, for now?
No, since I have started with centimeter, keep it as centimeter. Okay. A wire is stretched between two rigid support, vibrates in the fundamental mode. Fundamental mode, this is the fundamental mode, right? Of frequency 45 hertz. So for fundamental mode, this is fundamental mode. So the formula is this first harmonic, right? So nu is equal to 1 by 2L root of T by M. M is mass per unit length. Yeah. So now frequency nu is given as 45 hertz. Right, boys? The mass of the wire, mass is equal to 3.5 into 10 to the power of minus 2 kilogram. Density rho is equal to 4 into 10 to the power of minus 2 kilogram per meter. That's the linear density. Okay, fine. Now I have to find mass per unit volume. Sorry, mass per unit length. So mass per unit length. How will you do this, boys?
Ma'am, that's given, right? As linear density. Once. How will you do this numerical? Ma'am, is linear density the mass per unit length?
Linear? Yeah, mass per unit length is linear density. We do this numerical, boys. Just check how will you solve this numerical. 1 second, let me check all the values given are the same. Centimeters, meters. .45 hertz. Then the mass of the wire is okay, and its linear density. So how will I go for mass per unit length? Must think.
So do we have to find the length first and then substitute that in the equation of frequency to get the velocity?
Get me the formula. Go for the formula. Okay, what is a density? Density is mass by volume, correct?
Ma'am, linear density is mass by length here.
Linear density. If I go for linear density, sorry, then I have to go for length. So then what will be the length? Mass is given, right? What will be the length? Suppose if I take this as rho, so that will be mass by rho, right? So what is the mass? 3.5 10 to the power of minus 2 kilograms divided by linear density is 4 into 10 to the power of minus 2 kilogram. So Then what will be your mass per unit length?
Ma'am, mass per unit length, isn't that the linear density?
Linear density is the density for say what for per centimeter of the wire or per meter of the wire. What is that there to think was?
I'm getting 0.8.
Wait. This is linear density, that is mass per unit length. You have L, the length of the wire. Now, what is the question? What is the question was? Speed of the transverse. What is speed of the transverse wave?
Ma'am, the under root of tension by.
Speed of the, okay, speed of the, okay, what is the speed of the transverse wave? Is the tension given, boys? What is the speed of the transverse
Ma'am,
wave?
T by M.
M, mass per unit length, right? That is linear
Yes,
density
ma'am.
is given. Okay. T by M, mass per unit length. Now I can find this only if I know the value of your tension. Do I know the value of the tension? Is that the tension is given? Because what will you do? Such question comes. See, if I want to find V, anyway, mass per unit length, I can see here. If I want to find these two, I should know what is tension. How will I find for tension? Okay, this is a fundamental mode. So what is the frequency? Frequency of the wave in fundamental mode. When is your test and what is the fundamental mode? What is that? Nu is equal to 1 by 2L root of T by M. Correct?
Ma'am. Ma'am, density is same as M, right?
Linear density is mass per unit length. Yes.
Okay, ma'am.
Only thing is that you have to find the length. This is L. So, okay, I'll give you the value. It is 0.875 meters. Boys, a textbook question, generally textbook question often repeats. So, nu becomes equal to 1 by 2 into 0.875 into root of. Now, what is the frequency given? 45 hertz, right? So, this becomes 45. It's a textbook question. Into your tension divided by mass per unit length, that is 4 into 10 to the power of -2. If I want to find tension, this entire expression I have to square. So 45 squared will be equal to 1 by 2 squared into 0.87 the whole square into T by 4 into 10 to the power of -2. Boys, how many days left for your exam?
Can we find the velocity first and then find the tension?
Yeah, you can do.
Okay.
Boys, this is how will you do this?
Yes, ma'am. Yeah.
Okay, anyway, I will do later on. Just I finished this off. So 45 the whole square because you are squaring both the sides. 2 into 0.875 the whole square. Then the square root term becomes 4 into 10 to the power of minus 2. So Gen 2 happens to be 248 Newton. Now the question is speed of the transverse wave. Was V is equal to is 1 by 2L root of T by M. This is nu. Now what is T by M? Root of T by M is nothing but the velocity V. So nu is equal to V by 2L. So or V becomes equal to nu into 2L. So nu is your 45 hertz into 2 into the length of the wire is 0.875 meters. Just 78.75 meters per second. Complete this, boys. This standard equation you should know what is. Just the frequency, fundamental frequency, fundamental frequency nu is equal to 1 by 2L root of T upon M. Was what you do is tomorrow you have 0 period, first half is your you have unit test, sorry, practical test. Tomorrow
No,
you have
ma'am.
computer science.
Ma'am, we don't
Tomorrow
have
you don't have. Okay. In case if you're free, might be if I'm having some other class, you people what you can do is that you practice whatever numericals have been given. At least the first half an hour. Right, boys? No, otherwise this is your preparation. How will you appear for your exam?
Ma'am, can you give the final answer for tension?
Fine. Tension is the tension is here.
Okay, ma'am.
T is
Sorry.
equal to 248. What do you have next period, boys?
Ma'am, mathematics.
Oh.
Ma'am, can we say by the relation you took out nu equal to V by 2L that 2L equal to lambda?
No, because root of T by M is the velocity.
Yes, ma'am. So can we use the waves equation and say that 2L equal to lambda? No, right?
Yeah, because your L becomes equal to lambda by 2 because fundamental frequency. Yeah.
All right.
Ma'am,
Yes.
ma'am, can you upload these questions?
Oh, okay. Because I have to go for the other class. So once let me complete their class because sometimes what I do is
Like,
remove this.
ma'am, the
Yes.
concept is clear. I think it's just that like these questions have so many tedious calculations. Like,
Tedious calculation. No,
yes.
so
So will
that's what
in
I'm
the
telling.
exam
Like,
also will look at these kind of questions? Because it will take a lot of time, right? And time will be a big issue then.
the first time when you're doing, at least keep in class, you keep a calculator and do it fast, boys. When you're doing it at home, because in class I'm not getting enough time. So if you want to just keep in class, just keep a calculator. When you're practicing, you use without a calculator. Class hours when you do when you take a long time, I'm not able to complete the others type of numericals. I think so. Possibly today I'll finish the numericals of this chapter. At least I'll start with oscillations. Right? You can leave, boys. You can leave.
Thank you, ma'am.
Thank you, ma'am.
You use a calculator
Thank you,
for
ma'am.
fast calculation.